Welcome to a podcast on unit conversions, sometimes called dimensional analysis. You should get a sheet that I call the pink sheet, and on the front of the pink sheet are polyatomics, and on the back you will see this chart that says like prefix, symbol, example. It's kind of the numerical stuff that we will need in chemistry. So conversion factors are factors that you've probably used a lot in your life, and maybe you just didn't know they're called conversion factors. For example, if you were talking about milligrams and grams, there's 1,000 milligrams in 1 gram. Or you could flip-flop that if you needed it in a different direction. For example, if you were going to use it in a multiplication problem and you needed the grams on top and the milligrams on the bottom, you could flip it that way. So it doesn't matter which way it goes, you can flip-flop it, but it has to be in the proper order for whatever the question is asking you. So over here, these are all the prefixes: tera, giga, mega, kilo, hecto, decadeci, centi, milli, micro, nano. I don't know if that's pico, pico, who knows. Anyway, and they all have these lovely symbols. Micro is the weirdest one of all. It is called mu. It looks like a funky cursive U, but it's called mu. And then you got all these beautiful other symbols. And they can be written as conversion factors. So let's go to one that we know, like kilo. Kilo means 1,000. So if you had 1 kilogram, it would be 1,000 grams. If your unit, though, were kilometers, so 1 kilometer would be 1,000 meters. Or if you had 1 kiloliter, it would be 1,000 liters. And you could flip-flop this fraction such that 1,000 was on the top and 1 was on the bottom. It would just mean that you have kind of the plain basic units, the grams, the meters, or the liters, not all of them at once, just one at a time on top. And then you would have the unit with the prefix, meaning the kilo prefix, like the kg, the km, or the kl on the bottom. So again, you can use it this way or you can flip-flop it. And another one we are usually pretty familiar with is our friend Milli. I always like to think of Milli Vanilli, the group that did lip syncing, or I guess that's singing plagiarism. So anyway, if you had 1 gram or 1 meter or 1 liter, and there's also lots of other types of units, but in general we use grams, meters, or liters, you would have 1,000 milligrams or 1,000 millimeters or 1,000 milliliters. These other ones get to be a little more confusing, and again, you could write them in a different way. I just chose to write them this way for no particular reason. So if you had 1 gram, it would be 1 times 10 to the minus 12th teragrams. What's something else that we use a lot? Yeah, we don't use centi so much. We do use micro sometimes. So if you had 1 gram, it would take 1 times 10 to the 6th micrograms to make up that gram. And sometimes we use nanograms. So if you had 1 gram, within that 1 gram, there's 1 times 10 to the 9th nanograms. They're always talking about nanoparticles these days, and I think they're using the word nano because they're on this scale, 10 to the 9th. So we're going to use these conversion factors to do problems in chemistry, and we also have to keep in mind sig figs. Sig figs are going to follow you everywhere, sometimes like a bad smell. Here are some equivalent statements. If you need a particular equivalent statement, I'll give it to you on a test. And if it's not on the sheet, I'll write it on the board. I'll give it to you somehow or another. There are some things I do expect that you would know. For example, that 1 inch, sorry, not 1 inch, there's 12 inches for 1 foot, some things that you've just experienced in your everyday life. But for example, this, I don't have it exactly memorized, that 1 inch is 2.54 centimeters, or that 1 gallon is 3.78 liters. But here you can use these conversion factors. I just wrote them as equal statements, but they really will be written as fractions. And when you do this math, you want to have the numbers and you want to have the units. It's very important. Let's try this problem. It is a conversion factor problem. It's not too chemistry other than the fact that we'll use units, and I want you to set your problems up in a particular way. So how many minutes are in 3 hours? So we would write down the number 3 hours. That's what we're known, or that's what we know, or that's what we're given. We'd write 3 hours, and these are usually written as times, and we're going to have some kind of fraction. If we have hours on the top, then we're going to want hours on the bottom over here because they will cross cancel. And then we think to ourselves, do I know a relationship between hours and minutes? Let's see. Let me write minutes in there and let me think about it. I think I got it now. If I had 1 hour, I know that there are 60 minutes in it. And it looks like we can now do our math. So we would go 3 hours times 60 minutes divided by 1, and we would hit the equals button. But I like to look at my units to make sure they cross-cancel. So the hours there, cancel those hours there, and we're left with minutes, which is what the question was asking. So really and truly, my calculator, I'm just going to go 3 times 60, which is 180. I got rid of the hours. I'm left with minutes. And we have to follow the rule of sig figs. So usually we look at the very first number we're given. That's going to determine our sig figs. So this one had 2 sig figs. So our final answer should have 2 sig figs. The 1 counts as a sig fig, and the 8 counts as our other sig fig. And the 0 doesn't count because there's not a decimal or a line over it. So it looks like 180 minutes would be perfect. So if you wanted to get full credit on a test or a worksheet, you would have to write out what you're given, the unit, and the conversion factor, the numbers on the proper order, and the units. Let's try this next problem. How many miles are in 5.0 kilometers? So when I see this problem, I instantly see the 5.0. I know I have 2 sig figs, and I'm given kilometers, and the question's asking me miles. So I'm going to convert from kilometers to miles, and I think to myself, kids, I don't know anything off the top of my head about kilometers and miles other than the fact that they're distance. So I might pull out my handy-dandy pink sheet and look on there, and I know in this category here, there's nothing about a relationship between kilometers and miles. But if I investigate over here, I see that 1 mile is 1.609 kilometers. So I'm going to use that as my conversion factor. So I'm going to write out 5.0 kms times, let's move that a little further over, my lovely line. If I have kilometers on the top here, I'm going to want kilometers on the bottom there. That's how I know where it goes. So they cross-cancel. And then miles, because I saw a direct relationship between kilometers and miles. In fact, 1 mile was 1.609 kilometers. And I look and see if my units cross-cancel, kilometers, cross out kilometers. If it makes you feel better, you can put a line under that one and a 1. So it looks like you have like a giant fraction times a giant fraction, if that makes you feel better. And maybe it doesn't. And then I look at the unit on top. That's the one I'm left with, which is the one I want. But when I do the math, I have 5 times 1, because they're across from each other, which is just 5 people. And then I have 5 divided by 1, which is still 5. And the one I'm really concerned about is this number here. 5 is over that number, so it's 5 divided by 1.609. Get out my calculator. 5 divided by 1.609. And I know this number. I've seen this before. 3 dot, how many sig figs? 2 sig figs. 3, my calculator says 3.10. I can only have 2 sig figs, so it's 3.1 miles. Oh, I have done this before. I have run a 5K, and when I was running it, I thought to myself, I can do this because it's 3.1 miles. Now let's do metric to metric conversions. And I'm talking about using this chart here. And the question says convert 5.7 megaliters to liters. So I find mega. There's my mega. And there is on here, it's going to be megaliters to the regular liters. Let's push this out of the way just a wee schmit. And I'm going to write down 5.7 mega. Those must be really big liters. Times, I got to get rid of my megaliter, so that's going to go on the bottom. Let me look there. Oh, here it's on the top, but that's okay. I can write it on the bottom. I'm going to do 1 times 10 to the, what was that number? -6. And on the top is just 1 liter. I see the 1, and the unit is liter, so it's that. So now I go 5.7 megaliters times 1, which is still 5.7, and I divide it by 1 times 10 to the -6th. And when you do that calculation, you get 5.7 times 10 to the 6th. And sometimes I kind of cheat. I see that this number is a 1, and that's 10 to the -6th. If you're pretty savvy with math, you know that with exponents, if you have a -6 when it's on the bottom, on the top, it's going to be a +6. You just have to look at this number in front to see if it divided into that and made any other changes. So it's 5.7 times 10 to the 6th. In WebAssign, you do 5.7e +6, and it's liters. And so that really is 1, 2, 3, comma, 1, 2, 3, comma, 5.7 million. Hi. That's a lot of liters. It's probably like how much water's in a lake or something. Now we're moving on to a little more complicated conversion. We're going to go from a prefix unit, centiliters, to another prefix unit, nanoliter. So this is really a two-step problem, and by two steps I mean you write out the number that you're given, 3.30, and those are centiliters. I'm trying to write tiny, times, and we're going to have two conversion factors. So we'll have to get from regular centiliters, or centiliters, to regular liters, and then we'll have to get from liters to the nanoliters. I know you're capable of going through here and mixing it up and doing one conversion factor, but make sure you know how to do it with two just in case. So I'm going to, first of all, find the centi. So there's 100 centis for one regular thing. So it looks like I put this number on the bottom here. So there's 100 centiliters for one regular liter. And now I find my nanos. There's the nano. And it's 1 times 10 to the 9th nanos for one regular. I'm just going to cheat because I'm running out of space here. There's 10 to the 9th nanos for one regular. So in my calculator, I'm going to do 3.30 divided by 100 times 10 to the 9th. And I do have to be mindful of sig figs. I'm starting out with 1, 2, 3 digits, so my final answer should have 3 digits. Once you plug it into the calculator, I got about 3.30, look at that dot there, times 10 to the 8th nanoliters. I usually love it when you put a type of geometric shape, like a rectangle, around your answer. It brings great joy. And I do like to go back and make sure my units crossed out. Centiliters, crossed out centiliters. Liters, crossed out liters. And I was left with my friend nano, which is what I wanted. Perfect. Let's make sure you know how to enter this into your calculator, and when I talk about that. So if you wanted to put 2.1 times 10 to the 9th in your calculator, you would hit the 2, the dot, the 1, and you can't hit the times button because that doesn't quite work for this. You got to hit the second button, and then this button with a comma on it to get to the EE function that stands for, I don't know, scientific notation. So again, you go 2.1 second, EE, and then you would hit 9. And then in the calculator, it would look like 2.1, and it would actually look like a capital letter E. I always write the lowercase e because it's easier. My capital E's look really ugly. So if you wanted to put this next one in there, like 1.5 E minus 5, which it means times 10 to the minus 5th, you'd go 1.5 second EE, and that encompasses the times 10. And then you'd hit the negative button, not really the subtract button, but the negative button, and then a 5, and that would give you the number. And again, your calculator would probably read 1.5, a big E, and a minus, or a negative sign, and a 5. It doesn't do the little e, but I like the little e. And WebAssign will take a big E or a little e. It doesn't differentiate between those two. I hope this helped you with your lesson on dimensional analysis, and I will see you soon.